So this is a little different. And in that square, they contain some different sections, and then I think this goes across like this, yeah. All right, so now let's label this. They have A, G, D, this is E, this is B, J, and C, okay? And another proof, and it says we have two pairs of triangles. So technically, I've got like 4 triangles. Actually, I've got 6 triangles up there, I think. But we have 4 pairs of congruent triangles, or so it seems. We'd have to prove the congruence, right? But basically what we're asked to do is we want to prove triangle GED is congruent to triangle JEB. Okay? And E, and we're given this. This is given. E is the midpoint of AC and BD. Or DB, BD, whatever. All right, so it's not a formal proof, so we're just going to think our way through this. Well, the first thing that I'm going to do is I'm going to GED is congruent to JEB. So let me highlight that. We're trying to show that this triangle from here to here to here is congruent to this triangle from here to here to here. All right, we're going to think this through. I'm going to start with the stuff that's given to us. What's given to us is that E is the midpoint of AC and BD. So if it's the midpoint of AC and BD, what I have is that this is congruent to this line segment by definition of what the midpoint is. If E is the midpoint of BD, then what I have is it divides it into 2 congruent parts. Also, this angle here and this angle is congruent because what?
Because they're vertical angles.
Yeah, because they're vertical angles. So I have an angle and a side. Yes?
Wouldn't, I'm kind of continuing this, but wouldn't GE and EJ also be congruent because of the definition of midpoint?
It doesn't tell us that. It doesn't tell us that E is a midpoint of G.
Oh, okay.
GJ. We're assuming that, but we don't know for sure.
Okay.
So, but yeah. So basically, we have an angle and a side. We need either one more angle or one more side. Right? So, I'm going to label something though. Because it's a midpoint of AC, I don't know if this helps us, but those 2 line segments are congruent. Hey, you know what wait a second. I don't know how helpful this will be. How do we move past that? I've got to find one more angle. We got to prove it. We can't just guess. Yes?
I was thinking that we could prove the sides by finding the bases. So, like, if you have, or what I'm trying to explain, I guess, would be that you need to find, so using vertical angles, could we figure out the different sides, or, my brain.
Well, remember, this section is on overlapping triangles. Okay? So now watch what I'm about to do. Is this a triangle?
Yes.
Yes.
Is this a triangle? Yeah?
Yes.
All right. Now, if I draw those triangles separately, I have a triangle like this and a triangle like this, where this side is congruent to this side. These 2 sides are congruent. These are congruent because of vertical angles. Are those two triangles congruent?
Yes.
Yeah, so I could say that triangle AED is congruent to triangle BEC. Okay? All right, cool. Now, how does that help me proving the two little triangles? Well, if they're congruent triangles, then corresponding parts of congruent triangles are congruent, right? So that means those two angles are congruent. Or in other words, this is congruent to this. Correct? All right. So now I'm going to get rid of some of this orange because I got a lot of stuff up here. Let me delete that. Boom. Boom. All right. So now, by using this information here, I've proven another angle in my little triangles, right? So now I have an angle, a side, and an angle. I have an angle, a side, and an angle. So I could say with confidence that triangle GED is congruent to triangle JEB because of angle, side, angle. Does that make sense?